Okay, so let's try to code trace this quick before we run it through the visualizer and check how it works. So the postfix incrementers, like a++, where the plus plus comes after the variable, that's going to take the current value of the variable, but not increment it until after we use it in the expression. So the current value of a is 2. So in the expression, this is going to be a 2. But we have to remember then to go back and increment the value of a after we use it in the expression. So a++ is 2, but the value of a after we've used it now becomes a 3. Okay, then the other post-incrementer has precedence in Java. Before a pre-increment, we do a post-increment. So we're going to come over to the B++, grab b's current value, which is 3, and use that in the expression. Then we have to go back and increase the value of b by 1. So b is 4. So we used, for the two post incrementers, their current values before incrementing them, then went back and incremented them each. Okay, then in Java's precedence, we do the pre-incrementers. So from left to right, we come to plus plus b, and that tells us to first increment the value of b, and b's current value is 4. We're going to increment that to 5, and then use it in the expression. So b is now 5, both in its value as a stored variable and as its value in the expression. Okay, then we're going to do the same for the pre-incrementer for a. Plus plus a tells us to first increment the value of a held in the memory, and a's current value is 3, so we increment it to 4, and we're going to use that incremented value of a in the expression. So now Java's precedence has done the post-incrementers, the pre-incrementers. Now we're going to do the addition from left to right. So in the expression for C, we have integer addition 2 plus 5, which is 7, and then plus 3 plus 4 is another 7, so that's 14, but we're storing C as a double. So C is currently going to hold the value 14.0 because it's going to automatically widen and cast that int result as a double to store it as C. Then in line 9, we have a pre-incrementer. So we're going to take that plus plus C, and it's going to increment the value of C by 1 to 15.0. And then use that in the expression. But the 15.0 expression, it isn't doing anything. Like, it's not being stored as a value, it's not being printed, so nothing really happens in line 9 other than the incrementing happening. If you'd imagine if that was a post incrementer, if it was C++ on line 9 instead, it would have the exact same result. It would still just increment this to 15 because nothing else is happening on the same line. So now in line 11, we've got system out print A. A's current value is a 4. Then system out print line B. B's current value is a 5. System out print line C, and C's current value is 15.0.
15.0 just 15, remember?
Okay, so let's go over here to our visualizer and we'll see if that works. So see if I can get this over in the right spot. Okay, so we'll step through this code line by line. Oh, we need to go back to the first. So we'll hit forward, and the compiler stores 2 as the value of A in the memory, then 3 for the value of B, then it increases A's value by 1 to 3 after it put that 2 into the spot in the expression. Okay, then Forward again, now B has been incremented to 4 because of this B++ at the end. So it stored 3 in this spot in the expression, but it changed B's value to 4 afterward. Okay, then the A just got incremented to 4, and B got incremented to 5. And now the output from that expression stored 14.0 as a C. Now it's going to do C++ and added 1, so it incremented C to 15.0. Next it's going to print the current value of A to the console. Oh, which we need to move over here so you can see it. So there the 4 came out in the console. Then printed the line B, and the 5 came out in the console. And then line C, 15.0.